Welcome to this explainer, where we're breaking down a high-stakes battle that's shaping the future of AI. And this isn't a conflict being fought on some distant battlefield. It's happening right now inside the world's most advanced data centers.
Okay, let's just dive right in. At the absolute heart of this massive geopolitical showdown is something you could literally hold in the palm of your hand. We're going to be breaking down an article that shows exactly how this tiny piece of silicon became the central prize in a global power struggle.
You know, for years now, the US and China have been locked in this intense contest for AI supremacy. It's a race that a lot of people think is going to define everything: economic power, military advantage, and global influence for the rest of this century.
And when you strip it all away, it really just comes down to one thing: hardware. Yep, for all the amazing talk about sophisticated algorithms and these giant language models, none of it, absolutely none of it works without the physical foundation. And that foundation, it's the advanced computer chips that provide all that raw power. And right now, those chips are overwhelmingly made by American companies.
So, this brings us to the core of the whole conflict. It's a new kind of technological Cold War that experts are calling the AI chip war. It's basically a fight for control over the very building blocks of our future.
So what does that actually mean? Well, it means this isn't a war fought with missiles. It's being fought with microelectronics. You've got nations basically weaponizing their supply chains, using export controls and industrial policy as their main tools to try and get a decisive technological edge over the rivals.
And here's the strategic imbalance that really defines this entire conflict. While the competition in AI software and apps is, incredibly fierce, the physical tools you need to build that AI are dominated by one side. Nvidia is sitting at the very top of that pyramid, and that gives the United States this critical and pretty controversial lever of control. The huge debate in Washington is, what do we do with that power?
This imbalance has created a really sharp division inside the U.S. government, and it's led to a super high-stakes choice with two very different and very consequential paths forward.
Now, what's really interesting is how this whole debate is framed. On one side, you've got what they call the block strategy, just completely cut China off from advanced chips to slow them down. But on the other side, you've got the hook strategy, sell them powerful chips, just not the absolute best ones, to keep them reliant on your tech and maintain some leverage.
The argument for the hook strategy is actually pretty pragmatic. The people who support it, including Nvidia's own boss, they argue that a total blockade would just be a massive incentive for China to pour tons of resources into becoming self-reliant. And, in the long run, that could create a much stronger and more independent competitor.
But on the flip side, the block argument is all about national security. The hawks in Washington, they argue that any advanced chip sold to China, it doesn't matter how powerful it is, risks being used to advance their military capabilities. For them, that potential risk just far outweighs any economic benefit or strategic leverage you might get.
And who's caught right smack in the middle of this strategic tug-of-war? The undisputed king of AI hardware, the company whose technology everybody wants, Nvidia.
So, just how big is this relationship? Well, it kind of comes down to this one staggering number. According to our source material, a full 60% of sales for one of Nvidia's top AI chips went to China. That's not just a big market share, that's a foundational pillar of their entire business.
For Nvidia, you have to understand this isn't just another international market, it's a core part of their business. We are talking about billions of dollars in revenue. So this makes any decision by the US government to restrict sales, well, it becomes an absolutely existential issue for the company.
And this is why Nvidia is so central to this whole story. Their technology isn't just a little bit better, it is several generations ahead of their closest Chinese rivals. That technology gap means there's simply no domestic alternative in China that even comes close to matching their performance.
Okay, so faced with these two conflicting strategies and these immense economic stakes, what has the US actually decided to do? Well, that brings us to the current and very nuanced policy.
They've effectively chosen a middle path, a policy you could call a tethered cord. So first, they restrict the absolute best, most powerful chips. Then, they permit sales of custom, slightly downgraded versions made specifically for the Chinese market. And the result is control. China stays hooked as a customer, but they're kept on a technological leash, always a step or two behind the absolute cutting edge.
It is an incredibly delicate balancing act. The goal is to thread this tiny, tiny needle,
slow down China's military modernization by denying them the very best tools, but do it without completely severing the economic ties that benefit U.S. companies like Nvidia, and keep China dependent.
And this brings us to the fragile state of play today. This tethered cord policy, it is not set in stone, not at all. And it raises the critical question of what's going to happen next in this high-stakes game.
You know, this policy has been a constantly moving target. It has shifted and evolved under different administrations, and it keeps changing in response to new geopolitical pressures. This has created today's fragile tether, which exists in this constant state of tension, with many people in Washington continuing to push for a complete decoupling, to just cut the cord entirely.
And that leaves us with the final, crucial question. Is this policy of keeping China close, but controlled, a stroke of strategic genius that somehow balances all these competing interests? Or is it just a temporary, unstable fix, a frayed rope that's about to snap, with massive consequences for the future of technology and global power?